So just a little bit about me really quickly. I am the CTO at Mission, and little things about me. I'm a technologist and a programmer. I kind of came up through engineering. Love writing code. I still write code every day if I possibly can. If the team lets me, it even makes it into production from time to time. Been using the cloud since the very early days of the cloud, and have deployed multiple applications and grown multiple businesses on top of cloud, and exited a couple successfully as well. Also love bespoke suits like that one there. So who is Mission? Just really briefly, we're a AWS Advanced Consulting and Managed Services partner. So we have offices here, or in Los Angeles, not too far from here, in the greater Southern California, mega metropolis, and also in Boston. We're actually the combination of three different businesses, two here in Southern California and one in Boston, coming together over the last year. And we just came out with our new brand Mission. So we help businesses kind of across the entire spectrum of moving to the cloud. So architect, migrate, manage, and optimize. I'm not going to go into too much depth here because that's not what you're here to hear about. But we basically help businesses with that move. So what are we going to discuss today? How many people here have played with Lambda, serverless? All right. How many people here get asked about what's big data, or what's a data lake? A couple people, all right. So what we're really going to be talking about now is kind of a lot of the big buzzwords that are out there, but kind of making it a little bit more fun, right? Bringing it down to earth. I decided I wanted to build something that would be fun to talk about with people, but that would give you some really good ammo to understand how these technologies can be put together to do some really cool things. So we're going to start off talking about what exactly have I built. So I'm old school. I have a website. I don't have a Facebook profile anymore. I deleted that because they're terrifying. And on my website, I have this cool little floating window over here I call my current status bug. So right now, if you go to my website, you can see the current state of my phone charge, right? How charged up I am. You can see if I'm connected to Wi-Fi or not. You can see if I'm driving or walking or standing still. And there's a little pin there that you can actually click, and it'll take you to my current location on a map. That's kind of creepy, but sort of fun, right? Why am I doing this? Well, I also wanted to be able to dive deeper and actually, behind a private, I can log in and no one else can see it. I can go through and I can contextualize, where was I on a particular day? What was I doing? I store all my photos on my website. I do my check-ins on my website. Everything that most people put on their social media profiles, I put it on my site. Some of it's private, my journals, my notes. And then I can go in and say, hey, where was I on this day at exactly this time? Was I in a car? Was I moving? What was my elevation? Did I take any pictures? So for me, it's just sort of like personal data analytics. We do this type of thing for customers all the time on their kind of big enterprise workloads. But I really like to hone my skills and hone my team skills by doing kind of fun projects as well. So how did I build this? Well, at a high level, this is what the architecture looks like on top of Amazon. So I have my mobile device, my iPhone in my pocket, and I talk to a web service that I've built on top of Lambda. So it turns out you actually, if you want to build a kind of standard REST API or web service, it's pretty easy to do these days with Lambda. It takes away a lot of the burden of management, makes it really easy to just kind of fire it and forget. You only pay for what you use. And then I'm storing all of this data, this aggregated data, in a data lake inside of S3. We'll talk a little bit about that in a moment. Then I'm using some cool services from Amazon called Athena, which actually allows you to look in your S3 buckets and actually query that data with SQL, which is really neat. A lot of people don't think about that. They think about S3 as just a place you put blobs of binary data. You can actually put structured data there and then mine it. A lot of people aren't aware of that. Very, very useful. And then I have some kind of schedule Lambda functions for doing some kind of background work. And then I've integrated with some other APIs as well. So we're going to walk through this. I'm warning you, there's code. You're going to see code. If you don't code, that's OK. No, I didn't, but I would love to. Awesome. So great. Now, this is much better. So you're going to see code, and that's OK if you're not really familiar with how to program or the programming language that I've chosen or any of that. What's more important here is I really want you to see what's possible and see how these services work. So the first thing that I did was I was like, well, I don't really want to write a tool that's going to actually track my location on my phone. There's got to be something out there already. Turns out there was something, and it actually came from a friend of mine named Aaron Parecki. He built an app called Overland. It's for iOS. It's free on the App Store. You download it, you plug in an endpoint, and it just posts JSON data on a regular basis. So the hardest part was just collecting the data, and he did it for me, which is awesome. It's also open source, well-documented API. It even will kind of collect and buffer the data if you're offline. So for example, I travel a lot. I'll be on an airplane. I'll put my phone right next to the window so that I've got good GPS signal, and it'll just collect the data while I'm waiting. And then when I land, it posts all of that in batches, right? So that I can actually watch my track across the country. Pretty cool. So the JSON payload looks like this. If you don't know what JSON is, that's okay. The most important thing here is it's just data, right? It's some information about a timestamp, my current altitude, speed, so on and so forth. And each batch may contain multiple data points, and I can collect those together. So I wanted to, I've been writing web applications and web APIs for years and years and years and years. And I really wanted to do this on Lambda, and it's definitely possible to do. But you know, I've built web frameworks in my years. I've used a lot of them out there, and a lot of times I just want to focus on writing the code. I don't want to worry too much about all of the chaos behind me. So there's this great framework out there called Zappa that lets you use typical Python web service framework and then deploy it on Lambda. And it does all of the magic behind the scenes of generating CloudFormation templates, creating API gateway endpoint, mapping those requests in, and executing your Lambda function. Very, very cool. It'll even remediate cold starts. A cold start, does anyone not know, or does anyone know what a cold start is? Raise your hand if you do. Good, about half of you. A cold start is effectively when you hit a Lambda function after it's been a while since it's last been executed. And when you do that, sometimes Amazon will actually spin down the backing kind of compute that has that Lambda function. And so it has to spin it back up again or somehow locate it. And so you'll have a slight pause or delay in spinning it up. Zappa will actually remediate that by continuously executing that function every couple minutes, just to kind of keep it alive. Doing a no-op, right? And because on Lambda you only pay for your compute execution time, it costs you almost nothing to keep it alive all the time. Don't tell my partners at Amazon that does that. It has some other cool things, like it integrates with the DNS service Route 53, which I use, and it integrates with Certificate Manager as well, so you can generate an SSL cert, and put it behind your domain name, and all that good stuff. So I used Zappa, and I just created a little API. I called it Punytrack because I wanted it to be little, puny. And here's the code. Don't worry too much about it. But simply enough, there's an API controller here, and right here is an input, right? So data comes in on my token, and I store it in my backing store. And then if you want to get the current one, I ask to get current and return it back out again. So it's like 3 or 4 lines of code. There's some stuff up here for cores and privacy and blah, 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 blah. Don't worry about that. Okay, so now I've got this Overland app in my phone that every 5 minutes is sending me a batch of hundreds of data points. And I'm storing it. How am I storing it? So Amazon S3 is the answer. And this is how I'm creating a data lake. I store the current location in a known location, right? In a known object path in S3. I do that so that it's very easy for me to get the current location instantly. I don't have to do a query or search it, right? It's much more efficient for me just to store the most recent location and then fetch it back out again. And then I partition the data. So partitioning is a technique of knowing that I'm going to have a lot of data, and I want to be able to segment it into some sort of chunk, right? So in my case, I'm segmenting it by a token, so that this is actually a multi-tenant service. Somebody else wanted to send all of their location data to me that I could then use to mine that and put ads in their face, like Facebook. I could do that. So hey, any VCs in the room want to give me a whole bunch of money? I'm an ad tech business now. All right, I got at least one laugh. Thank you. So I also normalize the data, right? In this case, I'm partitioning by token. I later partition in addition by year, month, and day to make that easier to even easier to query. And then I store it. So this is the beginnings of a data lake. A lot of people are very confused. What is a data lake? Just a big old bucket of data, right? Has to be structured at least in some way. Otherwise, you have a data swamp. Okay, so how do I deploy? Well, I'm going into this JSON file that basically tells Zappa, the tool that I used, hey, this is my web app that I built, my little web API. This is how you execute it. pleased to be deploying it. And I just type Zappa deploy production, and off it goes. So once I have that up and running, here is a redacted with my token because I don't want you having my token, to see how the data is structured. So here in that bucket that I store my data, under current, this token, current.json. So my web API knows how to fetch that easily. And then I have history, right? So if I expanded this, there would be, at this point, because it's been running for quite some time, millions of objects, millions. And then on rollups, I actually have summaries on a daily basis. And I do that, again, because I want to be efficient. So let's talk a little bit about that. So the next up, I'm going to prep for Amazon Athena using something called AWS Glue. AWS Glue is essentially a managed ETL service. It helps you go through and create data tables out of disparate data and map that disparate data into those data tables. So they have a great feature called the Glue crawler. These are actually a little bit expensive to execute, but you don't have to execute them continuously. You can do it once or twice and be done. So what I did was I configured a crawler and said, hey, I got a bunch of data over here. It's in JSON format. You know, I've normalized it. Go figure out the structure. And it did. And here is my discovered table. So it has all of my columns. It understands my partitioning. It even determined the data types, including arrays, right? So my motion array. Very, very cool. So now I have a schema, and now I have Amazon Athena. So I've got this bucket of JSON data. I've got Glue, which has now crawled through that data and rationalized it into basically an SQL table. And I can literally query it. And you can even create views, which is pretty interesting. So I created a view that's just for my token so that I could redact that. And then I do the query, and the results get spit out. Boom. Very fun. So the next thing to do is you pay for these queries. So if I wanted to have a user on my website be able to see my current location, or be able to, if I wanted to go through and look at my travel for a particular day, I don't want to do that query on demand, right? That's inefficient. I'll be spending money for every single one of those executions on Athena. Athena's pretty fast, right? I think an execution right now for a daily rollup takes about 8 to 10 seconds, but I don't want to wait 8 to 10 seconds. I want to wait 0 seconds. So what I've done is in Zappa, I can go through and say, please call these functions using this cron syntax this often. And I do one halfway through the day and one at the end of the day, right? So that I can kind of start realizing my map in the middle of the day. And here's my little daily rollup function. All it's doing is calling, going through, looping through the data, querying it with Athena. I'll show you. So here's my query. Select star from history, where my token is this, and year, month, day is this, right? So give me today's date, and then output it to this place in S3. And then I execute the query. It's really easy to use. So now I want to integrate all of this craziness with my website. And it turns out that's actually pretty easy as well. You can see at the top here, I have a geo.cleverdevil.io is where I've mapped this Lambda service in API Gateway. And I pass it my token and say, on this date range, please give me data. And I pull it out into JavaScript on the client side and render the points using Apple's MapKit.js. So I've just done kind of a crazy fun thing. We've walked through this now. I use Lambda to generate, to build out a web application using Zappa, which turned into a nice REST API, storing data in a data lake, leveraging AWS Glue to map all of that data into logically queryable tables. Then I use Lambda again to use Athena to query that data and generate rollups that are then accessible by my API, and I integrated it with my website. So we've gone through this exercise. Nobody paid me for building this service out. We do things like this for customers. Let me give you some examples of what other customers we are working with have done using very similar technology. Embedded devices are everywhere. IoT is a very popular thing. We have worked with and are working with companies who have many devices out in the field, right? So for example, let's say it's an automotive business that may have a cell-connected device in a vehicle. They want to track locations for maybe insurance purposes, right? Have you ever seen those commercials before where Progressive or one of those insurance companies will say, hey, put this in your car, we'll track your driving habits, and if you behave, we'll give you a discount? that's exactly the type of use case you could do with this. You could store that data, literally send it up through an API gateway through Lambda, and store it in S3 in a data lake. You could store it elsewhere. You could store it in Dynamo, or you could end up piling things down into Redshift if you wanted to. But we see these kind of use cases all the time. Increasingly, as more and more devices exist, you need highly scalable ways to deploy out APIs. Because these devices can grow like exponentially, right, as people onboard more and more users, you don't want to have to worry about, I'll have to spin up another web server, right? Or even if you're using auto-scaling groups in AWS, you can scale up and down cleanly. The nice thing about Lambda is it literally scales with your execution, right? You're going to have more difficulty with how do I make sure I can store all this data efficiently than you are with how do I scale my web layer. API Gateway just handles all that for you. So I think it's an underappreciated use case for Lambda. So that's what I built. My conclusion is that it's actually a lot more fun these days to build out a web service because I'm able to think about other problems than the scaling-like problems, right? I write code in very similar ways that I used to, but now I can deploy them in new and novel ways that are much, much more efficient and a lot lower cost, and actually a lot more fun. And then I really had fun diving deep into Glue, S3, and Athena. There's actually another service called Redshift Spectrum that lets you use kind of the full power of Redshift against S3 as well. So that's very, very cool. Next exploration for me on this. All the source code for this stuff is available if you care to take a look.